Welcome everybody to today's session. My name is Andre. I'm going to be talking a bit about, actually before I start, let me just double check my screen share to make sure that's actually working. If you don't mind giving me 1 second. Zoom is always a bit iffy sometimes. All right, I think we should be good there. All right, so hi everyone, welcome to today's session, scalability and redundancy with fault injection. Again, my name is Andre, Senior Reliability Specialist here at Gremlin. I'm going to be talking a bit about, well, of course, fault injection, but also how you can use it to test your scalability and redundancy, and hopefully make your systems more resilient. Some quick notes before we get started. If you're new to office hours, welcome. This is an interactive webinar. We want to hear from you as much as you want to hear from us. So if you came with questions, or if you have questions that come up during the course of the webinar, please feel free to enter them into the Q&A panel or just hang out in the chat, and I'll make sure I get to them afterwards. After the presentation, after I do a quick demo, I'll go through the questions and answer as many as I can. This webinar will be recorded, so if you have to leave early, that's totally fine. We're going to send up the recording afterwards so you can catch up on that. And if you're new to office hours, this is a monthly series that we do on a variety of different topics. You can sign up and see our upcoming sessions at gremlin.com/office hours. And because these sessions are for you, we're always interested in ideas and recommendations for topics. So please, if you have any recommendations for topics or something that you want us to cover, let us know in either the form at the end of the session or our contact form at gremlin.com/contact, and definitely let us know. And again, I'm Andre Newman, Senior Reliability Specialist. I'm here to answer any questions that you have, so definitely don't be shy. So quick look at our agenda today. I'll start with a short presentation introducing the topic, just going over the basics. I'll talk a bit about, what different considerations you should have for scalability and redundancy when setting up your systems. I'll talk a bit about how to run resource and network faults, or what we call experiments in Gremlin. I'll do a quick demo showing you essentially a redundancy experiment, and then we'll leave a time at the end for Q&A. All right, so let's start with the absolute basics. What actually is fault injection? Well, fault injection is a technique for creating controlled failure in a computing environment. Controlled is in bold for a very important reason. Technically, you can create faults by walking up to a server, pulling the plug, but that's very chaotic and very hard to recover from. The reason we emphasize control is because that means that you have the ability to stop the fault at any time. You can decide which systems it impacts, and you can avoid making permanent changes to the systems that you're testing. So instead of just pulling the plug on a server, Gremlin and other fault injection tools like it do things like issue restart commands, shape network traffic rules to add latency or drop packets, or even temporarily change the system's clock. There's a whole variety of things that you can do. This is just a small example of it. The screenshot is actually an example of a CPU experiment that we have. The fault here is adding CPU load to simulate heavy load like you might get from a higher traffic period or from a lot of customers hitting your systems all at once. Think of something like a Black Friday event, or if you're in financial services, a nightly batch job. In Gremlin, all faults that you do have a duration. And at the end of that duration, they're stopped and that impact is averted. And that's how you get that sharp decline at CPU usage at the very end. So again, faults can include things like consuming resources, network outages, drop packets, latency, things like that. And then also changing the actual system states, like changing the system clock or terminating processes or shutting the system down. So a wide variety, they all test different things. And part of the key is knowing which ones to test and when, and of course, how to recover from them. So we're going to dive a bit into it. If I could get Dean to recognize the key. There we go. Sorry. So let's take this idea of fault injection and apply it to something like scalability. So the main goal of scalable systems is, of course, to adapt to changes in demand. So if we suddenly find ourselves with a bunch of incoming user requests, more that our systems can currently handle, we want to be able to dynamically add or remove enough capacity to handle them all as demand increases and decreases. Removing capacity is something that we mentioned because nobody likes paying for resources that they're not using. And if you're in a cloud environment, or even if you're on-prem, having hardware that you're not actively using is just throwing money out the window. So Scaling goes in both directions, up when you need to increase demand or meet increased demand, and down when you're responding to a decrease in demand. And typically we see scalability based on two metrics: CPU usage and memory usage. You can use other metrics if you want. Ideally, you do use one specific to your service or application, the one that you care about the most. But CPU and memory tend to be the most common ones and the easiest ones to demonstrate. If you're using a cloud platform like AWS or Azure or GCP, auto scaling is built right into the platform. It's in many cases just a toggle that you use or a few text boxes or parameters that you set. You basically just need to configure it and the platform takes care of the rest. So let's say we have a cluster of EC2 nodes set up running on AWS. We've got our load balancer in front of them that are routing traffic to them. And for the most part, everything works great. But you know that one day the traffic coming to the site is going to increase and you'll need a way to deal with that extra load. And of course, you can only vertically scale so much before whatever instance you have can no longer handle the number of requests that it's getting. So that's where auto scaling comes into play. And auto scaling, like I mentioned before, can be configured pretty easily in AWS. But even if you go through and you configure all the options and you know exactly what they do, there are still a lot of really open-ended questions. So for example, will the autoscaler work the way you expect it to? Did you set the right thresholds? How long does it take the autoscaler to kick in? And once it does, how long does it take for new nodes to come online? You still need to handle the incoming traffic even while your systems are scaling up. And depending on the complexity of your applications and the systems you're dealing with, that could be several minutes. So this is where fault injection really helps. And the way that you can approach a situation like this is by running an experiment that consumes CPU or memory in a way that simulates that high demand that you're trying to test for until you hit that scaling threshold. And once that threshold is reached, you can then monitor your systems and your cluster to make sure that it's scaled the way you expected it to. So what that looks like in practice, essentially you would go in, configure auto scaling on your cloud provider. Let's say, for example, to keep things simple, we want to scale up if our CPU usage across our entire cluster averages 80% for 1 full minute. We then use Gremlin to push CPU usage on all the nodes in the cluster up to something like 84, 85% as an example, and hold it there for at least a minute, ideally 5 minutes, just to give yourself a good buffer to make sure that it triggers. And what that should accomplish is it should trigger AWS to deploy a new instance to auto scale. If by the end of the experiment, you have a new instance up and running and your traffic's being served to it, great. It worked the way you expected it to. You can mark that as success. But if it doesn't work out that way, you have some more work to do and some more troubleshooting to do. But the good thing is that after you've addressed the issue or you've implemented a fix that you think it works, you've dialed in the right scaling thresholds, you just need to go back, run the test again, and validate that it behaves the way that you expect it to. So testing is sort of done on both ends. First, to make sure that the system operates the way you expect it to, and then again, to make sure that any changes you implement work the same way as well. And I'll also talk about that a bit more later when I get into automating testing. So one more quick note on this before I move on. I just pulled these numbers as examples. Scaling isn't universal. It's not really a one-size-fits-all thing. It tends to vary based on your service, the type of industry that you're in, the type of demand that you have, how quickly your demand changes, even things like how much money you're willing to spend. It's a bunch of different factors. For example, if you're a massive bank like Bank of America or Chase, you probably have different scaling needs than a startup or a small financial services company. So again, just depends on your needs and your requirements. This testing could be a lot more advanced and these scaling rules could be a lot more advanced than I'm showing here. I'm just showing these as examples. Another good resource to turn to is checking with your cloud provider's best practices. Like AWS has their well-architected framework. I think Google Cloud has something very similar. I even call it well-architected too. Just make sure you check that and see what they recommend and how it fits into your specific needs. All right, so next, let's talk a bit about redundancy. And the reason I'm covering these two is that they're both major uses of fault injection and some of the more common experiments that we see folks running in Gremlin. But redundancy is a little bit different from scaling. So instead of adding or removing capacity here, we already have the capacity provision. We just need to make sure that we can keep our service up and running, even if something happens to a bit of our capacity. So for example, a data center loses power, a server room floods, excuse me, or let's say a rack catches on fire. It sounds far-fetched, but these things do happen even to big, sophisticated cloud providers. Just last month, actually, or within the past month, I can't remember exactly, there was a big X or Twitter outage caused by a fire in a data center in Oregon. It did affect a lot of people, but it didn't affect everybody. So the fact that a lot of folks are still able to access the site and still make posts and read stuff despite the fire shows just how robust the infrastructure is. I can guarantee you, without knowing anything about how X's infrastructure looks like, that they put a ton of time and energy into making sure that it's super redundant. They can keep it up and running despite its major disasters like this. And a lot of other tech companies do the same thing. Chances are your team has put a lot of time and effort into this too. So it's a pretty important topic to go over and test through. So again, like with scaling, a lot of the big cloud providers give you the tools to add redundancy yourself, like being able to deploy auto scaling groups, setting a minimum number of nodes that should be provisioned within that group at all times, and doing things like using health checks to make sure that each instance is healthy and responsive. There's a lot of functionality just built into cloud platforms that you might need to go digging a little bit for, but it's absolutely worth it. Some of them, like data replication, take a little bit more know-how, but again, a lot of it is just available through the tools in your cloud platform. So it's just a matter of looking and making sure that you're adhering to your provider's best practices. So as far as actually testing redundancy using a tool like Gremlin, there are a couple of different approaches that we recommend. First is just running a straight up shutdown experiment. As it sounds like, this basically just shuts down or reboots a node and make sure that your system overall can either recover from that, and if not, reroute traffic to healthy and remaining nodes. Now, if you've ever heard of or used Chaos Monkey, this probably sounds super familiar. This is the exact same idea as that. The main difference is that Chaos Monkey would go and pick a random node to shut down, whereas Gremlin gives you a bit more control. You can still have it pick a random node if you really wanted to, but we also give you the tools to pick specific instances or even specific containers if you want to terminate those too. And I mentioned this first because it's the most straightforward approach. It's the one that most people are probably familiar with when they think of fault injection, but it's also the most disruptive, right? Once you run the experiment and that shutdown command is issued, there's really kind of no going back. And if you're not sure whether your systems can recover or not, then you probably won't have a great time. So option 2, which is my recommendation, is to run a black hole experiment instead. And the way this works is that it lets you drop network traffic from the node to a specific port or IP address or host name, or you can even do a blanket block on all traffic coming from the node to other systems. And what this does is essentially has the same effect as shutting the node down. Right? Other nodes can't talk to it. They can't communicate with it over the network. They don't know if it's available or healthy or not. Health checks won't work. So it's essentially simulating what would happen if that node was just totally unavailable. The benefit here is that with a black hole experiment, you can terminate it at any time. You could just go into Gremlin, click the halt button. Gremlin will issue a stop command to the node. The node will stop the experiment. Your network traffic will come right back up. And it would be like nothing happened at all. It will start communicating again with the rest of the cluster, with the rest of your environment. And again, it's just a very quick, easy way to revert back to normal without having to go back and check the instance to see if it's shut down or not. And the other main benefit to this is that Gremlin actually builds an exception into our black hole experiments and all of our network experiments for that matter, so that your node stays in contact with Gremlin's control plane. And what this means is that any traffic going to and from Gremlin, from your node, doesn't get affected by these experiments, right? It stays responsive, it stays quick. This way you can monitor the experiment's progress in the Gremlin web app while it's running. And like I mentioned before, you can send that stop or that halt command if you need your systems to go back to normal. So the way this works in practice is, I've had this sort of chart or diagram of a region shown up for a little bit. You've probably been looking at it for a while, wondering what it's supposed to represent. But I'll get to that in just a second. So let's imagine that we have this region set up and we have these different availability zones set up as well. Maybe we have different instances running in each of these availability zones, and we want to make sure that, if one of these is unavailable, that we're able to fall back to a healthy availability zone and keep serving our customers. So now let's say we want to take down all of the nodes in availability zone one. The way we do that with Gremlin is we'd select all the nodes in AZ1 as our targets. We'd select black hole as the experiment type. We click run. And just like that, Gremlin shuts down, quote unquote, that availability zone, or at least it shuts down network traffic to it. And according to the other availability zones, it appears as if that zone is completely offline. So case in point, we have an AZ failure. And when this happens, of course, we don't want to just keep our systems like this. We want them to be able to respond to this. So in this case, ideally what would happen is our cloud provider would recognize that this availability zone is unavailable. And if it needs to maintain a minimum number of hosts or a minimum number of AZs, it would automatically reroute traffic to another AZ or even a disaster recovery site. So we would run the experiment. We'd monitor our systems to make sure they perform this operation the way we expect them to. And if it happens without any problems, if it goes off without a hitch, then we've just validated our failover strategy just by running one quick experiment. And of course, if this doesn't happen, if we don't fail over to a disaster recovery site, or if we lose connection entirely to our application, we know we have some more work to do to make our setup more resilient. So there's a lot of flexibility in what this allows you to test. It's just a matter of figuring out which systems you want to target and which systems you want to monitor in response to the start of the experiment. All right, so before I go to the demo, there's just one more quick topic that I wanted to cover, but it's still very important. What do you do once you run your experiments and fix any issues that you found? And the answer is to automate. You'll want to repeat these tests pretty frequently. We recommend once per week if possible. The reason is because, probably unsurprisingly to all of you, systems change over time. You might deploy new code, you might make changes to your infrastructure, tweak your observability monitors or metrics, and so on. Meanwhile, your cloud provider could be making changes behind the scenes, performing operating system updates, software upgrades, software replacements. You might get patched in a way that doesn't always play nice with your software. And there might be regressions. That's kind of a scary word to any software developer, but it's a fact of life. Problems that we fixed in the past can and do often creep back up unexpectedly. We're all human. We all make mistakes. None of it's intentional, but it does happen. So we need to be aware of it and we need to be able to test for it. And Gremlin has two ways mainly of approaching this. First is creating scenarios. I'll show you in the demo in a second about how to run a basic experiment, but a scenario is essentially a collection of experiments that you can run sequentially or in parallel. So for example, let's take that black hole experiment. Now imagine if you wanted to simulate a cascading failure. So one AZ fails, and then maybe two AZ fails, and then maybe an entire region fails. And we want to make sure that with each of those steps, we can fall back safely to another region. This is where a scenario comes in handy, because you can create a scenario that contains three black hole experiments, with one targeting one AZ, the second one targeting two AZs, the third one targeting an entire region. And Gremlin will just go through and run each of those experiments in sequence as part of that scenario, so you can get that full testing coverage that you need to make sure your systems are responsive. Likewise, you can also run these experiments in parallel. So let's say you want to make sure that systems can fail over to a second AZ, but that they can do so while your systems are under heavy load. So you can run a black hole experiment on an AZ, and at the same time, run a CPU experiment on your other AZs to simulate that heavy load. Run these both in parallel and make sure that, as traffic gets shifted onto the remaining systems, that heavy load isn't straining them or making them crash or doing anything crazy like that. So that's really where scenarios are powerful, is having those different experiment workflows and testing these different, scenarios that you want to use to make sure your systems are resilient. The second approach, which is shown in the screenshot, is to use what we call test suites. Now, put simply, a test suite is a collection of scenarios that you can then run on each of your services. So with scenarios, you're essentially going and you're selecting which systems you want to impact every time you run the scenario. But test suites work a little differently. Instead, you define your test suite using your scenarios. You then define your services in Gremlin. You only need to do that once. And from there, you can run each scenario in the test suite against whatever services you define in Gremlin. It's just a much easier way to test a whole bunch of services at once and to make sure that they follow the same reliability standards. You can take a test suite that you've created and apply it to a bunch of different Gremlin teams. So everybody's being tested to the same standards, and the reliability scores you get from running these tests are, easy to match across your entire organization. And there are also a couple of other big benefits to test suites. First, of course, like I mentioned before, you can build your own. If you have a test suite, if you have a scenario that you want to use as part of your test suite, all you need to do is add it. You can either create a new test suite from scratch or clone an existing one. Then you can run it on all of your services. But test suites also have a second big component called detected risks. And these are just basic configuration issues that Gremlin automatically looks for. Things like if you're running Kubernetes, do you have resource restrictions enabled? Do you have redundancy enabled? Do you have your pods running in at least 2 different zones? Things like that. The main thing behind detected risks is that they can be evaluated without running any tests at all. Pretty much as soon as you add your service to Gremlin, Gremlin's already going through and checking them for that. You can see in the screenshot that the service has 4 detected risks, which isn't great because, that's kind of a lot. But if you go in and click into it, you'll be able to see exactly which ones have been marked as at risk. And we also include information on how to troubleshoot, how to fix it. So you don't need to go too far to find out how to bring that number down to 0. But we don't have the ability to create custom detected risks right now. You can choose which ones Gremlin looks for by editing or creating a different test suite. So for example, if your team or your organization doesn't run on Kubernetes at all, you can pull out all the Kubernetes runs. We do recommend keeping all of them in there just because Gremlin will evaluate them if they know it's not relevant to the service. But something that you can look into and customize yourself. That's a totally different office hour session, though. There's a ton I could talk about with test suites and detected risks. So if you want to learn more about that, definitely check out that session. But I did want to mention it in case you ran into it while you're using Gremlin, or, just in case you weren't aware of it and wanted to check it out. So with all that preamble out of the way, I'm going to jump into a quick demo. I'm going to focus on redundancy for this demo. Honestly, it's very easy to demonstrate. It gets the point across pretty well. And it's something I think that most people can relate to. So what I'm going to do is first, I'm going to show you the application that we have running. So what this application is, it's a really small, simple demo application that's like a bank front end. Basically, you can see that I can log in as my user account. I can see for whatever account I have, my account number, my current balance, my transaction history. I can deposit funds if I want to. I can transfer payments to a different user. All of these are different services running on Kubernetes. And I'll show you in a second what that looks like in Gremlin. But I just wanted to give you a quick preview of what it is that we're going to be testing and what we expect it to look like. And just to show you that this is actually live, if I refresh the page, it refreshes pretty quickly. My balance is changing because I have a process running in the background that's making deposits automatically. And if I really wanted to, I could come in and say deposit $100 and say I just got paid today. And it shows up pretty much right away. So the baseline for this application is it's pretty fast, it's responsive, everything's working the way we expect it to. Now let's see that if one of these hosts fails, how or if that affects this application. So what I'm going to do is I'm going to open up Gremlin. I open it up on the list of agents that I have. And these agents are basically just the host where I installed Gremlin, the Gremlin agent. That's what allows me to run tests on these systems. So I want to make sure that the agent is installed on each of the hosts that I want to test. And the hosts I'm going to focus on today are these 3 Gremlin lab worker hosts. So you can see that for each host, we grab certain types of metadata, like the operating system, the host name, the IP address. But more importantly, if these are running in the cloud, we can also grab the region and zone that they're running in automatically. So you see this one is in US East run. The second run is running in US East 2, and the third run is running in US East 3. So a pretty good distribution of hosts. Um, if any one of these regions or zones fails, we should be able to fall back to one of the remaining ones. But again, this is something that we want to check to make sure that is actually working the way we expect it to. So what I'm going to do here, I'm going to go and run an experiment. This is just a really quick injectional fault to test a hypothesis quickly. You can see the different types of experiments that we have, but I'm just going to go create a new one. Gremlin lets you select different types of resources that you want to target, whether it's hosts or individual containers or Kubernetes resources. In this case, I'm going to target hosts, and that's for a very specific reason. For hosts, this is where we gather information about the regions that we're running in. So you can see that if I scroll down, we have a category for zone and for region. I see all the different regions that my hosts are running on. So let's click US East 2 as an example. And when I click on that, the components in my infrastructure, or the resources in my environment that are going to be impacted by that are highlighted automatically. So you can see that there's this Gremlin Lab Worker 2 host running with all these different containers in it. These are all the ones that are going to be impacted by this experiment. I also have this random sort of stray host right here that's also going to be impacted. I'm honestly not sure what that's about. That's kind of an unintended benefit of this too, is that if selecting one of these tags is going to impact something that you're not expecting to, you'll be able to see it here. But, for the sake of the demo and for the sake of experimentation, let's just keep that one selected. So now I'm going to scroll down and I'm going to expand, choose a Gremlin. We're looking for a black hole experiment, which is going to impact the network. So I'm going to go to network and select black hole. Again, this is where we whitelist the Gremlin control plane so that my host can keep communicating with Gremlin and stay in contact with it. So I'll leave that as is. What I am going to do though, is I'm going to increase the length. We'll say 300 seconds or 5 minutes just to be safe. I'll leave all the rest of this the same. You can see where we allow you to configure certain things like which IP addresses are going to be impacted, which ports are going to be impacted. If you want to target a specific service, like an AWS service, you come down to service providers and select that through here. But I'm just going to leave those blank for right now. Under run experiment, you can choose whether or not to schedule it for later, but I just want to run it right now. So I'm going to click run experiment. And now it's going to take a few minutes, or not a few minutes, but it's going to be a few seconds while the experiment starts up. This little break period is enough for you to review the experiment's parameters, make sure it's what you want it to do. And also, if you want to come in and to halt the experiment, let's say you accidentally clicked run experiment, or you didn't mean to run this exact one, you have a bit of a buffer to come in and halt it if you need to. But I'm going to let this run, and then I'm going to go back and I'm going to check my web application to see if it's still running stable. So let's just do something simple, refresh the page. You can see it's taking a little bit of time to load, which isn't a particularly great sign. That probably means that either my load balancer or my front end isn't working correctly. And while the page did refresh, you can see that the current balance is unavailable and the transaction history can't be loaded. So this is a particularly great experience, right? If I was a customer at this bank and I came in and saw this, I'd be wondering, like, where did all my money go? What happened to all my transactions? Do I still have access to this? Like, there's a lot of questions that come out of this. And if I was working on this application, as a developer in the bank, this would be my sign to do things like, add more customer-friendly error messages, like, we could not retrieve your balance. Please contact your branch, or we could not load your transactions. Please contact your branch. Something along those lines, just to make the customer feel a little bit safer, to just give them something a little less scary to deal with. So yeah, even though this was just one region and we have hosts running in 3 different regions, we still had that bad experience. But now though, we are able to get our front end and our balance back. Our transactions are here. So it tells us that maybe our cluster did recognize that there was a problem and that it automatically failed over to those 2 remaining regions to bring our service back up to normal. So we had a failure at once. Our systems recovered automatically for them. Now we just need to know that we need to go back and figure out what caused that initial issue, Should we make our Kubernetes services more redundant by default? Should we have more nodes running in different zones? We would just need to balance that against our need for availability and how quickly we can recover. But this is just to give you a quick idea about the types of tests that you can run with Gremlin and the type of impacts that you can be looking for as a result of them. So now that we've seen how that works, I'm going to come in, I'm just going to stop this experiment. You can optionally give a reason for halting it if you want to, but you don't have to. I'll just put confirm. Gremlin's going to send that halt signal to the agent running on that host, telling it to wind down the experiment and return its my networking rules back to normal. And now that it's halted, I should be able to go back and refresh my bank and everything should be working normally. I can still go in, deposit funds. I got an extra $100 because I troubleshooted this live and the deposits are successful. Everything's working the way we expect it to. So everything's back to normal. So this was kind of a quick example of how you can approach this. One other thing I'll show, since I talked about it during the course of the presentation, is what services look like. So if I come back to Gremlin, I back out of experiments and I instead go to services. Each of these is the Kubernetes service running that's providing the different functionality in our bank. So you can see we have a front-end service that serves the website itself. The transaction history is its own separate service. The balance reader that I showed you is its own separate service, and so on. And if I click into any one of these services, this is where our test suite comes into play. So for each of the scenarios in the test suite, you can see the result of the last time we ran it. You have the option to run it quickly just by clicking this run button. And if you click into any of the test results, you can see the full history of the test, including the most recent run and any runs that happened in the past. Any runs that happened in the past? That sounds grammatically incorrect, but I'm going to stick with it. So you get a lot of visibility into this, but more importantly, you get visibility over time. So you can see how the service's reliability has evolved. And of course, we wrap this all up in this really nice reliability score that shows you how well you're scoring on each category of tests. So the front end, you saw is pretty good in terms of redundancy. We had a few seconds of a delay, but it responded pretty snappily after a little bit. We're having some issues with dependency testing. You see we have some failures there. So that's a pretty clear indicator to go in and rerun those tests or to see why they failed. And if you want just a really good high-level overview of your entire Gremlin team, we do offer reports as well. You can come in and see the score across your entire team. I'm honestly not sure how well my team is doing, so this might come as a surprise. Okay, 79%. Not bad, not awful. There's a lot of work that I could still do, but in general, it's okay. Not trending in a great direction though. You can see that I was averaging around 80 before, and there was a little bit of a dip. So again, that's another sign that I should really go in and see what exactly is failing and how I can go back and fix that. But again, this gives you just a really good high level overview of how you're faring across all of your different services across your team. And we do also offer company level reports, but I'll let you look around and play with that and see how that works too. So yeah, that was the demo of how redundancy testing works, at least one example of it. Before we get to Q&A, just want to give you some information on how you can get started. First, if you're already a customer, you already have access to everything I just showed you. You can just head to app.gremlin.com, log into your account, and start running experiments. Maybe coordinate with your team first before you start running experiments randomly on different systems, but you can go in and run them pretty much immediately. If you're not a customer yet, you can always get a free trial at gremlin.com/trial. We offer access to our full environment for 30 days, no credit card needed. So you can always just head there and sign up. If you're not ready to jump into the product just yet, though, we also have free, fully interactive demos available in our democenter.com, available in our demo center at gremlin.com/demo-center. These look just like a web application and walk you through common workflows like running tests, accessing reports, onboarding your services, managing test suites, all sorts of cool stuff. So definitely go and check those out. And lastly, if you found this session useful, which I really hope you did, we'd love to see you in one of our future sessions. We do these monthly. And if you head over to gremlin.com/office hours, you can see the next topics that we have planned when it's going to air. but you also have access to all of our previous sessions too. So you can go back, see those, and watch those recordings if you'd like. There's a lot of really great stuff there. We've been running these for about a year and a half now on a whole bunch of different topics. So definitely go back and check those out and see if there are any of that interests you. Um, Before we head out, I just want to say thanks so much for joining us today. I really do hope the session was useful for you. We do run these sessions for you all. So again, if you have any topics to cover, any questions you've ever had about Gremlin or reliability testing or fault injection, we're totally receptive to them. Please feel free to write us and request any. Um, we do run these monthly. So if you'd like to join these, head over to gremlin.com/office hours and please feel free to sign up for a future one. Even if you can't make the live session, that's totally fine. We do send out recordings of all of these and post them on our website afterwards. In the meantime, again, I hope this was helpful for you. Hope you're able to learn something from this. I hope my Zoom missteps weren't too jarring at the start of this session, but it does happen. We work in the reliability space. We're kind of used to working around failures, so it does happen. But again, thanks so much for joining. Appreciate your attendance and hope you have a great day. Have a good rest of your week.